Have you ever drained your pool and got down to the last few inches of water and wonder how you're going to get it out of there? Well, man, I've got the solution for you. This two-part video will explain this solution. The first part will be an overview of how the system works. The second part will describe how to build a receptacle duty cycle controller. When draining your pool with a siphon, a problem occurs when the water gets very low. The end of your siphon hose starts to pull air and loses its suction. This will leave you with a few inches of water at the bottom, depending upon the size of your siphon hose. The easiest method that I've found to remove the water is to use a 10-gallon shop vac. The problem with this is that it's very labor intensive. You have to vacuum the pool until the shop vac is full, turn it off, drain the tank, reseal the tank, turn it back on, and repeat the cycle over and over and over again. And it takes all day long, and it's very cumbersome. I needed to automate the system. So I built a duty cycle controller for a receptacle that I plugged the shop vac into. This is the same as turning it on and off with the button, except it's automatic. You can see here in the video now by the hose jumping that the vacuum is on, because the controller has the vacuum energized. Now here's the magic part. Ready? Here it comes. The shop vac has automatically drained itself. This occurs because I have replaced the tank plug with a simple, crude check valve. So when the controller turns the power off to the vacuum pressure inside the tank is removed, and then the weight of the water simply opens the check valve and pushes its way out. The check valve is basically a piece of flat plastic sheet. In my case, I used a piece of Kydex that I had available. To install the check valve, just remove the plug of the shop vac. Tape the piece of plastic to the shop vac with a bend on the end so that it fits snugly up against the drain port. When the shop vac is energized, the vacuum in the tank will seal the drain port with the piece of plastic. When the shop vac de-energizes, the weight of all the water in the tank will push its way out. So here's the check valve in action. Right now the shop vac is on. You can see the plastic is sealed to the port holding the water in due to the vacuum pressure inside the tank. When the vacuum pressure is lost, the weight of the water pushes open the check valve and drains to the outside. The duration of the drain period is set on your duty cycle controller. You'll see in a few seconds the check valve close when the vacuum turns on. Wait for it. There, the valve is closed and the tank is filling again. Well, that's pretty much it. That's how the system works. One other lesson learned is that the end of the hose of the shop vac cannot be fully submerged in water. It requires to pull in some air to lift the water to the tank. Fortunately, the shop vac hose floats. You can see in the video here as the hose gulps a bite of water and then a bite of air, causing the hose to bounce. There were occasional cycles where the hose was submerged and the shop vac did not lift water properly. This fortunately would correct itself in the next cycle and didn't require any intervention. It takes a little trial and error to determine how long the shop vac should stay on and how long it should stay off. There's no real risk of overflowing the shop vac by leaving the on time for too long. The shop vac has a float switch that will release the vacuum pressure when the level's too high. Well, here's the vacuum starting itself again, completely unattended. So while this vacuum worked itself all day, I had much more important things to do, like goofing off and eating, playing video games, and of course, took a big nap. So I got the pool all completely drained and cleaned out. The automatic shop vac controller proved useful even after the pool was emptied. With the vacuum hose on the bottom of the empty pool, I used a water hose and a broom to sweep the algae and sediment on the bottom of the pool to the vacuum hose. This saved a lot of time from having to stop and manually vacuum. So the next part of the video is about how to build a duty cycle controller. It'll be a bit more technical because it involves relay logic. I'll explain it step by step though with drawings to illustrate. Well, I hope you enjoyed the video. Please leave your comments below, and if you're interested in seeing the duty cycle timer design.